Okay, this is chapter 21 in Withgott. It is the third about energy sources, and this one is on new renewables. So, wind, solar, and geothermal, and things like that. So, the case study at the beginning of the chapter on 589 is about harnessing the wind and the sun in Texas and Germany. Germany has actually been a role model in terms of converting to renewable energy, and they've done a lot of different things that we could look to them as a model to see what works. Texas is kind of interesting because it used to be a big oil state, and a lot of their wells have played out, and so they've been looking for different things, and they have actually, because it's in the Southwest, they've got a lot of sun, and it's in the plains, so they have a lot of wind. So they've actually converted a lot of land to wind and solar. So, interesting case study there. Then section 1 is about shifting to renewable energy and how new renewable sources are growing fast. We're going to skip over to page 592 and start talking about like some of the what we consider renewable energy. So you should know this figure and caption here. This is the US consumption of renewable energy by source. And then this is actually the US generation from renewable sources. What you should know is that biomass is our largest renewable energy source in the US. So if you look right here in the renewable chunk, biomass is the biggest portion of that. And the reason for that is because of ethanol and biofuels. So that's like taking into account transportation stuff. Hydroelectric is the largest renewable electricity source. So when we're generating electricity, hydropower is our largest renewable for that. Here it's showing you greenhouse gas emissions, and you can see what we consider renewable are far lower than the non-renewable traditional sources like natural gas, oil, and coal that we have been using. You should know this figure and caption here for like the cheapest electricity sources in each part of the country. So here in the southeast where we are, natural gas is the cheapest, over in the northwest as well. In the middle of the country, in the Midwest, it is wind because across the plains there is a ton of wind. And so if they can harness that in that region, it's very cheap. And then you have utility scale photovoltaic cells here in the Southwest where there's a lot of sun, and a little bit surprisingly here in the upper Midwest. All right, so this science behind the story is basically just, can we produce enough renewable energy to power our modern lifestyles? So that's definitely worth looking at. And then when we get to 596, it's kind of, well, what can governments do? So in a democracy, governments are not able to just mandate things like easily. They can pass laws and things like that, but that takes a lot of political will and capital. So some things that they can do to promote renewables: they can fund research and development of renewables, so they can put money in universities and think tanks who are doing research on those. We could end subsidies for fossil fuels. Believe it or not, as profitable as they are, the billions of dollars that they're making, we still subsidize fossil fuels. Your taxpayer dollars go towards oil and coal. And instead, we could use that money to subsidize solar and wind. And so those then would become cheaper because they're getting subsidized by taxpayer dollars. They could implement something called feed-in tariff policies, and they actually do this in Germany. So what this means is that utilities pay premium dollars by law for renewables. So that means, like solar generated electricity would cost a little bit more. But then the renewables get priority to be sold first. So if you were a farmer and you have some land and you want to put some wind turbines or photovoltaic cells up on that, then you are guaranteed income by this law that would say utility companies need to buy the renewables first, and they need to buy them at a premium amount. We could also offer tax credits or rebates for photovoltaic cells or wind in homes, and this actually happened in the passage of last year's Inflation Reduction Act. They have subsidized a lot of renewable energy sources: photovoltaic cells, wind power, people buying hybrid and electric vehicles and things like that. So this is something that government can do and has done. And then finally, there can be something called net metering. And so homes that have solar and wind can sell their extra kilowatts back to the utility company. So they have a meter on their house where they can actually, if they have excess, it goes back out into the grid and the utility company will pay them for it. Okay, so the next section is about solar. There are lots of types of solar other than just the panels that people tend to think about. First, there's something called, we'll look at this one first, passive solar heating techniques. People have been using these for thousands of years. So passive solar heating techniques require no energy input. It's just building design. So you can do something where you have like south-facing windows to capture the sunlight in winter. So around here, if we had a bunch of south-facing windows, it's, you know, if it's sunny in the winter here, it's really not that cold. So the sun would come in and it would warm up the house, and it, you know, the house, and that's free heat. You can, in the summer, put some overhangs to shade windows so that you don't get the heat coming in. So you have stuff like this pergola up here that gives shade, and so you don't get the heat coming in. So you have to be able to move those things around a little bit. You can also have, this wouldn't be great here per se, but like in the upper Midwest or in the Northeast where it's really cold, you can have heat absorbing construction where your bricks are made to absorb heat, or there's something called straw bale construction where the basically kind of the insulation inside the house is made of very tightly packed straw, and it will hold heat. So any heat that gets absorbed will be held. And so that's, you know, money savings right there. Also, we can plant vegetation to buffer temperature swings. So if you have a lot of plants around the outside of your house, they will keep it cooler in the summer and they will keep it warmer in the winter. So all of those are passive building design, vegetation, landscape design type things that you can do, require no input of energy. Then there's opposite of that kind of is active solar. So you have to have some sort of solar collector. This is not a photovoltaic cell. This is just something that's going to collect heat, and it's going to then use that to heat up water, or sometimes it's air, very rarely, or antifreeze or something like that. But it's going to heat up some sort of substance. That substance then is going to get pumped through a system. And so that heat, like radiators, you know, in older buildings or places like that, a radiator just has hot water go through it, and that heat is then radiated out into the room. So you can do something like that here, where you just collect the heat of the sun, and then you pump that heated liquid through, and it could heat up air, or it can be stored in a boiler or something like that. So this is called active solar because you do have to pump that heat. And so the pump is what makes it active. Okay, turning the page. Now we are looking at another way of solar power that is not still not the photovoltaic cells that we'll talk about last. So this is a concentrated solar collector. And we may have talked about this already in class, but it's basically mirrors. These are not photovoltaic cells. They're not made of silicon or anything like that. They're just mirrors. And the sun's rays come down onto it, and then they get reflected onto this central tower. And then the central tower gets very, very hot. And so either there can be water inside there that gets heated, and it can turn a turbine, just like every other source of energy that we've talked about, or that heat can be stored in, by melting ionic compounds like salts. So that's talking about this right here. One of the problems with this, though, is that it gets really, really hot. And if a bird flies through there, it can actually get fried and like die instantly and fall out of the sky. But that doesn't happen very often, but it is one environmental concern with these. Another way of concentrating the sun's rays that people have been using for a while is a solar cooker. So it looks something like this. This one is in India. Basically, you put your food in the center, and then you concentrate the sun's rays. Same idea here, where all the reflection is going to a central point, and you can cook with that. It's a portable oven. Some people actually have these, and they take them for tailgating and stuff like that. Finally, solar power that most people think of when they think of solar power are photovoltaic cells. And it's important that you know that the AP exam does not call these solar panels, they call them photovoltaic or PV cells. And so these are the ones that are made of silicon, And the ones that you're used to seeing maybe in a solar farm or on top of somebody's house, you might even have some. And the way that these work is that the light strikes the silicon plates, and then that causes a release of electrons, and the electrons flow through the little wires that are inside the panel. And the flow of electrons is really the definition of electricity. So the fact that the sun kind of knocks those electrons off of the silicon pits and forces them through the wires is directly creating electricity. So there's no turbine like in every other source of power generation that we've talked about before. So you should know how photovoltaic cells work. There are many benefits to this. So you should know in each of these sections it talks about benefits and drawbacks. So you should make sure you check in on those. Some things to talk about: houses with PV cells that are on the grid are still connected to public utilities. And so in the summer, like around here, if it gets really hot, even though it's like you're probably pumping out a lot of energy from your solar panels, it might not be enough to run your air conditioning and everything else. So you can still supplement power if needed. But you can also sell your excess if you are on the grid. If you are off the grid, so if you live in a rural area, if you built a house way up in the mountains or something like that, you would need a battery system to store power for nighttime or anytime that the sun is not shining. So it is good for rural areas where connecting to the grid is expensive or impossible. And a lot of times you'll hear people say, oh, I want to live off the grid, and they can set up a system like this. Generally, even if you are connected to the grid, you still, if you install PV cells, you generally get a battery storage system with them as well. This just really quickly, this map kind of shows you where the best locations for solar, for PV cell placement are. And you can see obviously the Southwest and the desert, but here where we are is not bad. So it's something to look into for your own personal use. Some drawbacks to solar: it's not always sunny, right? Sometimes it's cloudy, sometimes it's nighttime. Additionally, it's not always sunny in certain climates like Seattle. Although there have been a lot of increases in PV cell technology recently, and so even places that are not maybe climatologically suitable or didn't used to be are now able to generate electricity with PV cells. Another big drawback is the upfront cost of the equipment. It costs a lot of money to have them installed, and it takes sometimes decades for them to pay themselves off. And so that's, not always feasible for a lot of people. There are some systems now where you can lease the PV cells, and I think it is cheaper than buying energy from power plants, depending on where they get it from. Solar energy is the fastest growing renewable right now, but it still only supplies a very tiny percent of the U.S. electricity. As of the writing of this book, it was about 1.6%, so not very much. All right, and then this picture here is basically just showing you, though, how the price has come down. And as the price came down, production ramped up. So down here, it's just simple supply and demand there. All right, the next one we're going to talk about, wind power. So you should know this is the standard wind turbine. Sometimes there are vertical ones, but this is the standard one. So you have the large shaft that goes up so that the turbines are elevated and are able to catch wind better. They want them to be above the tree line and things like that. And so these are the blades. And then inside, right, the blade is technically the turbine, and the turbine spins and it goes to the generator, which produces electricity, exactly like every other power plant that we have looked at up till now, right? Other than the concentrated solar. So you should know this figure and caption. They're basically converting kinetic energy to electrical energy. Wind power is growing fast. There is another sort of supply and demand curve here that shows as the price went down, production went up. You should know that China leads the world in most power from wind. 36.4% of wind capacity in the world is generated by China. But you should know, if you look at this, Denmark is the highest percentage of wind in terms of like generating its own. So Denmark gets almost 50% of its power from their own on-site wind turbines. Another type of wind power that you should know about is offshore wind. So this is the same exact turbine, only it's placed offshore in the ocean. And I'm sure that all of you have been to the beach and you know how windy it can be there. So the wind is most consistent here. So it's a really good location because there's almost like always wind blowing offshore. The problem is that people don't want to go to the beach and see the wind turbines offshore. It kind of like ruins their vibe, you know? Again, here's the part about the benefits, and you should read that. And there are some drawbacks that I did highlight here. Some of the drawbacks are, much like solar, it's not always windy. Sometimes it's not, okay? Some places aren't windy. So again, much like solar. And then one thing is birds and bats can fly into these blades and get killed. So like if they're just not paying attention and the blades aren't spinning that fast, they judge the, they go through and they judge it wrong and they can get hit and killed. This is particularly bad for bats because bats are so important to the ecosystem. They do pollination, they eat bugs, and they're actually having a lot of trouble right now because of diseases that are going through their population. So we really want to make sure that we are protecting the bats. And then finally, there's this concept of NIMBY, which stands for not in my backyard, where people are like, I really like the idea of wind, but I just don't want it in my neighborhood. Put it somewhere else. And this is true of so many things. Landfills, oil rigs, just, fracking. People are like, oh, I like the idea, but I don't want it near me. And so it tends to get shunted off into lower socioeconomic regions. This is showing you like average wind power. And again, you can see that the Midwest is the best place for that. Okay, and then this is just how well do wind and solar complement one another in Texas. So Texas is surprisingly a leader in wind and solar in the US. Should look at that. Okay, the next one is geothermal energy. Geothermal is mostly in the western US. That's where there tends to be a lot of the geothermal hot spring activity, and not as much on the East Coast. But what is geothermal? Basically, groundwater that is heated by magma. It can be used to heat homes and buildings directly, or the steam can spin turbines for electricity. So if we look at this picture here, like you could just tap into that heated water and you could use that heat. Or if you have an aquifer here where the magma is pretty close to the surface, then it will turn your aquifer into vapor and steam, and that steam will come up, turn the turbine, just like any other power plant, go into the cooling tower and condense and get injected back into the aquifer. So this would be a steam power plant. It does produce a little bit of hydrogen sulfide gas, which is a pollutant, but not that much, far less than the sulfur dioxide produced by coal power plants. Iceland does lead the world in geothermal production. This is a picture of a power plant in Iceland, and you can see it, barely. It's not a blight on the landscape or anything like that. It is considered renewable unless this aquifer gets overpumped. So if you also use this aquifer for water, like you're pulling it up for irrigation or water to drink and things like that, you can overpump your aquifer and it won't generate enough steam then to turn the turbine. Another geothermal source of power that you should know is called ground source heat pumps. And this is a really neat system. I'm like always super fascinated when I talk about these. So what this means is you think about the idea that underground is almost always a consistent temperature. If you've ever been down in a cave deep enough, you know that it's pretty much always like maybe 50 to 55 degrees underground, which seems pretty cool in the summertime, but it's actually kind of warm in the wintertime. So in the summer, if you run your pipes down deep enough, you can run air through them and the air will sit down there and it will get cooled by the fact that it is underground. And then you can, so this is like the hot air coming down and cooling off, and then you can pull that cool air into your house and basically air condition your house almost for free, just for the cost of pumping the air through this system. And then it's cooled by being underground. And then in the wintertime, kind of the exact opposite. If you think about your furnace, if it's 30 degrees outside and you pull that air into your, did I say thermos or furnace? Anyway, furnace. If you pull it into your furnace, the air, the furnace has to work hard to turn 30-degree air into 70-degree air. But if you pull it from underground where it's 50 degrees, then it's actually easier to heat and takes less energy, gas or electricity or whatever you're using for your furnace to heat it up. And so you can have this system, and year round it can be a benefit. So you should make sure that you know that one. All right, and then again, here's the section on pros and cons. So you should look over that. We're looking into ocean energy sources. We do have wave energy, and it's being used a little bit offshore on the West Coast. I don't know of any East Coast locations. There might be some. But obviously the idea is that you have a turbine, and the turbine gets spun by the waves coming in. So the waves are always coming in. And so you get the waves coming in, they spin the turbine, and generates electricity. And then there's tidal energy, which is a similar idea, only it's taking into account the tides going in and out. And so you have the ocean, and then you have this basin, and again, just a turbine. The turbine spins, generates electricity. And so the turbine it can spin when the tide comes in, and it can spin when the tide goes out. And so it takes advantage of the incoming and outgoing tides, constantly moving throughout the day. This shows a power plant in South Korea that was started in 2011. And so we do have a model of it working, but it has to be in a location where the tidal difference is very large, where the difference between high tide and low tide is big. And so these are kind of like they're in use, they're experimental, they're not really at scale yet, but they are proven to work. A theoretical ocean energy source that we're still looking into is called ocean thermal energy conversion. And this has to do with the idea that the deep ocean is cold and the surface ocean is warm. And can we take advantage of the currents that are flowing in between that temperature gradient? So you should know that one as well. All right, and then we also think about, what about storage with renewables? If we have the sun shining and we collect a lot of electricity, we can use it right then, but if we don't use it, we lose it. So we don't want to waste it. So what are we going to do with this excess energy? Obviously, the main thing that we think about is batteries, and we can pump it into a battery and, like a rechargeable battery and recharge it. And then you would have that energy available to you at nighttime or on rainy days and things like that. And then there's also this idea called pumped storage of water. And this is really our primary means of energy storage. We use this in a lot of different ways. What you do is you pump water up to a higher elevation, and then the energy is kind of stored in the potential energy of its position, and you can let that water flow back down through gravity, and you can recapture the energy as it's flowing due to gravity, and you don't have to do anything for that. So initially you do have to input some energy to pump it up to a higher elevation, but then the water flows downhill to generate electricity when the demand is high. Then the last thing in the chapter that you should know about are hydrogen fuel cells. Hydrogen fuel cells are kind of like a battery, kind of like an engine. They're kind of like a mix of different things. But this picture right here shows you a hydrogen fuel cell and what happens. You've got hydrogen fuel coming in. You've got these electrodes here, and as it moves through the electrodes, it will combine with oxygen, and so the only byproduct is really heat and water. So it is a very clean technology. The hydrogen fuel cells, though, in order to get that hydrogen, we have to split water right now into hydrogen gas and oxygen gas through a process called electrolysis. So it's basically you take water, you put some electricity into it, and it'll break it apart into hydrogen and oxygen gas. Does take a lot of energy, though. So right now, we're more concerned with how can we, actually I'm talking about this on the next page. The problem with this is that we use fossil fuels to power the electrolysis. So why not just use the fossil fuel to generate electricity and not go through this extra step? But obviously we're doing it to see if we can make it more efficient so that it actually becomes a better option. Additionally, they're experimenting with algae that may potentially be used to produce hydrogen gas. Hydrogen is abundant. I mean, it is the most abundant element in the universe. and we'll never run out of it. So if we could harness this energy source, it would be a really good option for us. All right, that's chapter 21.